So let's start with projectiles, week 6. First thing that you need to know are some vocabulary. The first one is, what in the heck is a projectile? A projectile is the object that is shot through the air, and a trajectory is the path of that object. And in a projectile, the path is going to look like this. It's going to be half of a circle, pretty much. So let me give you some examples. If you have somebody who's shooting a free throw, the projectile is going to be the basketball. The trajectory that it's going to take is going to look like this on the way to the hoop. Next example is somebody hitting a golf ball. The projectile, the object that's flying through the air, is the golf ball. And then the path is going to be this shape that the ball is going to take. Tennis ball, if somebody hits a tennis ball, the tennis ball is the projectile, that's the object that's flying through the air, and its trajectory is going to look something like this. Obviously, if you're playing a heated match of tennis, you usually want it to be less of a loop, but it's still going to have some sort of a loop. So now let's see some examples. So again, you're looking for the path that the object is taking. So watch as I shoot and the path that it follows. Next, I have the golf ball and the golf club. And with any luck, I might be able to get this baby up in the air. I hope you could have seen that. Third one, excuse me, is a tennis racket. And if I hit a projectile, again, you're noticing the path of that ball. Now, when you're using projectiles, if you want your projectile to go the maximum distance, you want to hit it at a 45-degree angle. That's what's going to get you the farthest. Now, the cool thing about projectiles is if you want two objects to fly the exact same distance, what you can do is you can actually make them leave at complementary angles, or angles that add up to be 90 degrees. So for example, I have here, if I shot something up at 75 degrees, and if I shot it at 15 degrees, it would land in exactly the same spot. The 15-degree one would go much lower. The 75-degree one would go much higher, but they'd land in the same spot and be a relatively short distance. 30 and 60 add up to be 90 degrees. They are complementary angles as well. A 30 would go relatively low. A 60 would go relatively high, but they would land in exactly the same spot. So if I take two tennis balls, and I'm going to, again, looking from a horizontal, if I go up 15 degrees and throw a ball, and if I go up 75 degrees and throw a ball, I can get them to land in the exact same spot. Now, clearly, I didn't measure my angles, so I should have been pretty close given my estimate. Now let's talk about the vectors that go with those projectiles. So the path that you're going to take, again, is a half of a circle when you're using a projectile. So what's going to happen if I hit the golf ball is that that golf ball is going to travel up, and at some point it's going to hit the peak or the top of its arc. At the top, for a split second, that golf ball is at 0. As it keeps coming down, it's going to get faster and faster and faster in the vertical direction. The horizontal direction is determined by the velocity that I hit the ball with. So you will notice that the horizontal vector on curved motion is always a constant speed. You will notice that every single one of those horizontal arrows is the exact same length. And the reason is because the horizontal vector is the vector that follows Newton's first law. It's the vector that wants this object to go in a straight line at the exact same speed and not change. These are your vertical vectors. You will notice that your vertical vectors are constantly changing. Here, my object is going upward, so the net is going to be a positive. And it gets smaller and smaller and smaller until it eventually gets to 0. Why is that? Well, it is trying to go up, but at the same time, gravity is pulling it down. And eventually, gravity gets to the point where it ties, and then gravity starts to win and gets accelerated more and more and more until it reaches the ground. So this is what your horizontal and your vertical vectors would look like if you were doing a projectile. Remember, horizontal vectors are all constant. They want the object to go in a straight line according to Newton's first law. Your vertical vectors are the ones that are changing, and they are constantly changing that whole entire time throughout the path, throughout the trajectory.